Hi, everyone. Welcome to this session on introducing Spring for Apache Pulsar. My name is Soby Chacko. I'm in the Spring engineering team, primarily working in the Spring Cloud Stream area of things, Kafka binders, Kafka Streams binders. But in the context of Apache Pulsar and Spring, I'm the co-founder of this Spring for Apache Pulsar project, along with Chris and
Chris Bono, software engineer on the Spring team, work on Spring for Apache Pulsar and Spring Cloud Data Flow and some of the Spring Cloud Stream applications. And today what our agenda is going to look like is we're going to introduce you to Spring for Apache Pulsar. We're going to talk about what is Pulsar, what is Spring for Apache Pulsar. We'll give you a high-level overview, and then the best part is we're going to write some code and do a live demo. After that, we'll leave some time for Q&A.
Just out of curiosity, how many of you are using Pulsar or Spring Pulsar? Have you tried Pulsar in your projects or just, okay, that's good, so that we can basically talk about it from the very foundational perspective, right? So what is Apache Pulsar? Apache Pulsar is actually an open source project that is gaining a lot of traction out there. It provides essentially various flavors of semantics to your messaging and streaming apps, distributed messaging and streaming. So it kind of gives best of both worlds. If you are familiar with things like ActiveMQ, RabbitMQ, and Apache Kafka, which is kind of so prominent out there, in the case of RabbitMQ and ActiveMQ, we have the queuing semantics. You basically work at the abstraction of a queue, right? And in the case of Apache Kafka, you have the log-based data structure. You basically append your data to a log. So although they both are coming in the messaging domain, the way you interact with them from your application is entirely different. One, you are working at the queue semantics level, and on the Kafka side, it's the message log. In the case of Pulsar, the great thing is that you have the benefit of having both of these flavors in your application. If you want to work it as a queue, Pulsar allows you to do that. If you want to treat it as a message log like Kafka for streaming use cases, it can do that. So Pulsar has a lot of built-in cloud-native mechanisms for multi-tenancy, geo-replication, and things like that. So it's actually getting a lot of traction. If you look at the statistics on the project, you can see that project is growing with a lot of people are interested in it. There's a growing community out there. So under the hood, what's happening is that Apache Kafka Apache Pulsar has this notion of stateless brokers. So if you look at the broker in Kafka, so the Kafka's broker is stateful, meaning that in Kafka, the storage is actually part of the broker. So you cannot separate both broker and the storage. They are like one unit. So so that is like more like a stateful broker. So in the case of Apache Pulsar, you have a stateless broker, which means that you can basically take your storage elsewhere, and the broker is completely independent of the storage. So the way Apache Pulsar accomplishes is that through another Apache project called Bookkeeper. So the Bookkeeper allows you to have like multiple ledgers. So in the same way Kafka has logs, Pulsar has ledgers. So these ledgers resides in Bookkeeper. So the benefit is that you can scale your brokers, infinitely, thousands of scale, or more than that if you want. So in Kafka, that is not possible because of the limitations of the fact that you have your storage along with your broker. So it's very hard to scale the broker itself in Kafka, but Pulsar allows you to do that. But keep in mind that this is different from the consumer scaling. In the case of consumer, that's different. Kafka allows you to scale your consumers. Pulsar also does that. But that is one of the main selling points for using Pulsar in enterprises. All right, now coming to Spring for Apache Pulsar. What is Spring for Apache Pulsar? So it is actually a project in which we feel like we need to provide Spring-friendly abstractions in the same way Spring provides messaging support traditionally. For example, back in the days, Spring added support for Spring JDBC or Spring JMS. We had JMS template, JMS message listeners. And then when Spring AMQP started, the same patterns continued. In the case of RabbitMQ, we have RabbitMQ template, message listener container there. And then these days, Kafka, Spring for Apache Kafka provides the same sort of design patterns like Kafka template, the message listener container through handy annotations like Kafka listener and things like that. So Spring for Apache Pulsar brings the same kind of flavor to the messaging needs of your application. Spring loves messaging, from its initial early days onwards, messaging applications go hand in hand with Spring. Spring provides great gateway to writing, these messaging applications, easily. So I mentioned that Pulsar comes in the domain of messaging and pub/sub patterns. So Pulsar accomplishes this thing in a number of ways. So the basic unit of data that moves in Pulsar is a message. There's a Pulsar message in the same way we have, in Kafka, you have a Kafka record. Pulsar, there's a message. And then there is abstraction of topic. So you basically communicate to Pulsar using topics. You have the option of partition your topic. That's another big difference that Pulsar has with Kafka. In Kafka, partition is the basic unit. In Pulsar, whether you have to partition the data or not, it's optional. It's basically based on the use case. Unless your use case demand it, you don't have to have a partition topic. And then you have publishers that publishes data, which is basically producers. And in the case of consuming records, consuming messages, you have a subscriber, which becomes your consumer application. And then you have a flexible subscription. So I mentioned that Pulsar allows you to have both queues and streams. So it has different, on the right-hand side, what you're seeing is different modes of consuming from data. So the exclusive subscription basically means that there can only be one subscriber under a particular subscription, which is kind of, again, if you want to compare to Kafka, it's the anonymous consumer group. So if you don't have a consumer group, or if you only have one consumer group and one consumer in it, if you have a different consumer group and you can consume from the same topic. In the same way, the exclusive subscription, as the name indicates, is an exclusive subscription for that subscription. So at the bottom, you have a failover subscription. That is more like, in comparison to Kafka's, what is it? In the case of failover, you can actually have a topic and then have multiple partitions and then consume from multiple partitions. So you can fail over, even within an individual topic, multiple partitions can fail over. So that is more like, in comparison to Kafka's, partitions and how you have, multiple consumers scenario. And in the shared subscription, the subscriptions are shared. The only thing is that if you have a shared subscription, there is no guarantee of ordering. You cannot, if you don't want to have ordering, you can rely on the shared subscription. But if you want to rely on ordering, you can either go with exclusive or failover. The upshot here is that Pulsar allows different types of subscription modes using which you can actually organize your application based on your use case requirements.
And so if we look at the architecture a little bit here, this is a simplified version of it, but from the leftmost side, Pulsar gives Pulsar client APIs, and they have bindings for multiple languages, pretty much every language out there. We're interested in the Java bindings because we're Spring for, we want to put a Java front end on it. And so if we go a little bit deeper, they have a reactive client and an imperative client. And so the first thing that we do in Spring for Apache Pulsar is we auto-configure these clients in. So you can go into your YAML file and put spring.service, pulsar.service URL, start up your app, and you can inject in a Pulsar client or a reactive Pulsar client. One step further is we also provide basic produce and consume via a Pulsar listener and Pulsar template. So if Soby mentioned Kafka template, there's JMS template. This is that Spring messaging template pattern where you Pulsar listener, you annotate a method, you say, I want a user object or a list of user objects, it'll be delivered to you and you can do whatever you need to do on it. Vice versa, on the sending side, there's a Pulsar template to do sends. We also have a reactive flare of that. If you have the reactive starter on the class path, it'll auto configure the reactive Pulsar listener and templates. We're going to go through we won't cover the reactive today during the demo just because we don't have enough time, but we're going to do the imperative. We'll do a send, receive, and then do some other interesting things with it. Some other noteworthy features is we have some limited support for Pulsar IO and Pulsar functions. And so Pulsar IO is Pulsar's connector framework and allows you to basically set up sources to feed data from external systems into Pulsar, and on the other side, sync data out of Pulsar into external systems, Rabbit. There's a handful of other binders. And the function support is their serverless compute framework. And what they mean by serverless is you can get a piece of logic that you want to consume a message from, operate on, and publish out. And so the interesting piece of that is that the function actually runs on the server. It doesn't run on a different process. And so that lets them scale up and do other interesting pieces. What we do is if you configure a bean that's of type Pulsar, connector, source, or sync, we'll go and register those apps with the actual server. See, the downside of these things is that because they run on the server, you have to go tell the server, here's a function, here's a source, here's a sync, and so we make that easier. We also, error handling and dead letter topic and retries. Pulsar has native support for this, but their support is only on shared subscription model, and so we extend that further so you can use it for other subscription types. They also provide a reader API, and so we've talked about consumers, and consumers you tell the consumer, give me some data, and it gives you the last piece of data wherever the offset was. So give me some more data, it continues to manage those cursors. The reader API is more flexible. You just say, give me the data from A to Z. Give me the data from here to there. And so we also auto-configure in a reader. Automatic schema and topic detection. So if you have an event of type food that you're sending around and you always don't want to, it's always going to go to the same topic and you always want to use the JSON or say Avro serializer for it, you can set it up so that anytime that there's a default for that message type, and so that way it simplifies a lot of the API calls. And Soby, you want to talk about these?
Sure. So as Chris already mentioned, in the case of Spring Cloud Stream, we have this notion of binders for each messaging system. So if you have Kafka, we provide Kafka binder. Kafka Streams as a Kafka Streams binder, RabbitMQ binder. And there are different public cloud broker-based binders out there. So along the same line of thinking, in the next version of Spring Cloud Stream, we have a dedicated Pulsar binder, which means that you can essentially express your input and output bindings, and then you can connect to a Pulsar destination, which is a Pulsar topic. And then Spring for Apache Pulsar also provides Graal VM native image support, which means that you can actually write your applications and then run them native on Graal VM, and then executing against Apache Pulsar. And then we provide built-in observability using the Micrometer project.
And we're going to demo the first two of these bullet points. We're going to put in a binder, and we're also going to run it through the Graal VM grinder and see how much faster it'll make it. And so, benefits.
Yeah, so the benefits here is that if you are writing Pulsar Java applications, there are some boilerplate code that you have to write, over and over again, right? So you have to create your own, Pulsar producer. You have to maintain the life cycle. On the consumer side, the same thing. You have to basically subscribe to a consumer. You have to worry about what kind of subscription mode you are in, things like that. So Spring for Apache Pulsar, like many other Spring projects, make the life of developers much easier because Spring provides a lot of abstractions for developers to use right away. It increases the velocity of your project, so you can focus on your business logic primarily, and then worry about those type of concerns rather than worrying about low-level messaging-related in this case, Pulsar-related things. So in our thinking, in our opinion, these frameworks add a lot of value to your, business development application needs, actually.
Cool. And so now we're going to jump into the live demo. Maybe we'll be able to show the developer velocity and experience here with some code. So the first thing I want to do is come over here to start Spring IO. We'll pick Gradle, Java 3.1.
Well, you have to exit the presentation.
Okay, here. And exit it or exit show?
End is fine. Yeah.
Okay. Yeah, here we go. Thank you, Artem. Okay, so I picked Java 17 and COM, Acme, Pulsar. Let's come up here to dependencies. Let's see what we have for Pulsar here. Cloud Stream. Let's go one step at a time and just pick basic Spring for Apache Pulsar. I'm going to explore this. I've already generated the shell just so y'all don't have to watch me flail around trying to copy a folder to another folder. And so I have this base project up here that it generated called Pulsar. And if we come into the build Gradle, I'll paste it in. That's just what came out of there. Let's pop Gradle and then come over here to Pulsar application. And so the first thing we want to do is a basic produce and consume using the Pulsar template and Pulsar listener. And so we will create some user object. So public record user, we'll give a user a UID and an email. Okay, we're going to simulate like a system that brings in a bunch of users, and then we want to write them to a topic. So let's do a public interface. Oh man, interface user service, and let's say it has user next user. Let's do something here. Oh, you know what I didn't do? We need one more thing here. That's okay. Flux, explore.
So Spring Initializer is a great way to start these type of projects, as Chris is demonstrating here.
Yeah, we're going to go back through here piece by piece. As we add a binder, and we're going to go back and get the dependency from. So I've added a web flux, and you'll see why in a second. We're going to use this new handy HTTP interface. If y'all haven't seen this, take a look at it sometime. It's really nice. And so you can tell I just wrote an interface that's going to return a user, and then down here, we just have to have this bean. This piece is unrelated to Spring for Apache Pulsar. I'm going to have a service that goes out to a random data service to pull in our users. And so let's call this user service, and let's say web client builder, web client builder. Let's say web client, var web client. randomdata.api.com/API-v2. If you haven't seen this website, it's pretty cool. It generates a bunch of different types of data, credit card data. It's good for testing. And so now what I want to do is if I take that interface, HTTP, service proxy factory, create builder, web client adapter, for client, web client.
This is completely independent of any Spring Pulsar related stuff. This is just setting up the data component here.
I wanted to show the HTTP interface stuff too.
Yeah.
If y'all haven't seen it, it's pretty cool. And so what this will do is go hit out to the service for web client.build. That's because I did not do this. Okay. Great. So we have a service that'll spit back fake users. So what are we going to do with that? Let's come up here and let's auto wire in our Pulsar template that we've been talking about. We're going to pass in users. Okay. Let's now create a method called source users into Pulsar. Okay. And so what we want to do is say pulsar template.send user topic user service dot. Oh, let me also putting auto-wired and field injection, I don't recommend. We're doing this all in one single class because it's a demo and you can see everything in a page. We're also going to do system.out, so don't do this at home, right? Okay, here we go. So we've injected our template, we've injected our user service. Next user, okay. So what's going on here? We need to, we'll just do that for now. This returns a message ID that tells you some information about the message after it's sent. What we're going to do here is produce, oh, I can't spell, produce, and we'll say message ID. Okay. Okay, great. Well, how do we kick this off? Let's go ahead, and we want to do this every second, so we will kick on scheduling, and we'll say scheduled, initial delay.
Chris, do you want to talk real quickly on line 29, how Pulsar template understands that user like that? You know, it looks like we can inject any type there, right?
Yeah, you can, and so how is that going to go across the wire? How is that going to get serialized and deserialized?
Right.
By default, we use JSON. And so Pulsar has the concept of schema. And so when we get to the Pulsar listener, or even here on the send API, I could say next user, but then schema type of, what if I wanted to do Avro, right? And so you could say Avro and user dot. And so
So it looks like in the case of user, it automatically infers that.
It infers JSON, and that's what we're going to do for now, and that's a pretty good default. Mm-hmm. And so right now what we've done is we've produced messages every second into Pulsar. That's the theory here. And so let's run it and see what happens.
Before you run because where do you run Pulsar? Where is Pulsar running right now on your local environment?
Oh yeah. I'm running Pulsar right here in Docker Compose, so that's the server's going there. And so now when I hit the play button, we're going to see a system.out that says message, so it's going to have some information about the message ID. And now it's actually not going to like the fact that I did this. Circular references. Class, user, service, config. Don't worry, this will take just a second. What this is the latest Spring Boot and framework are a little more tighter as far as, because this bean is defined in the same class where I need it, it says, how can I create something and use it at the same time? Mm-hmm. So we just put it into a static class for this demo. Always use proxy method false. Okay, now, okay, it's going to say produce. Okay, wait, that's really exciting. So now let's prove that it's actually producing. Let's say topic equals. I'll tell you what I'm doing in a second. I have this. Pulsar has a command line utility where you can actually go interact with it. So I have this script out here.
I'm going to bring this terminal a little bit.
What's that?
Move it up. Do you want to move it up, the terminal?
This one?
Yeah.
Let me see. I'll make it a little bit bigger. And so I'm just proving that we're sending messages outside of Spring Pulsar. So I have this handy dandy alias I've set up. See, these are the messages that we're sending in. So produce, consume. So no tricks up the sleeve. Let's come back over here. Let's consume inside of our application. So the way that we do that is we say Pulsar listener, topic, user topic, right? And then we come over here and say void log users, okay, log users from Pulsar. Okay, take a user, and here all we're going to do is sys out 1, 2, 3 consume user. Okay.
So this Pulsar listener is a very handy annotation, as Chris mentioned. Basically, behind the scenes, there is a bunch of things happening. It creates like a message listener container. The Spring Pulsar creates a message listener container, which actually starts the actual Pulsar consumer. So all those things are like boilerplate code. Otherwise, it's abstracted in like one simple annotation called Pulsar listener here.
So we've done basic produce and consume right there. And so I'm going to stop this, and that's somewhat interesting. And so let's say that we want to do something. We have users coming in, and now we want to register the user, and we'll give it an attribution of some type of tier, either free, basic, or standard, and we'll just do that randomly. And what we want to do is introduce Spring Cloud Pulsar, the Pulsar binder, in the middle of our, really we have a source that's sourcing the data in, and then we have this other method that's syncing to the listener is our sink in a sense. And so let me create the objects real quick here. So we have a record here for user. Let's create public record, registered user. It's a user that also has something called a tier. So what's a tier? Enum tier, and it's going to look like free, some money, a lot of money. Okay. That's it. So if y'all haven't used records yet, they're pretty nice. All this does right here is it basically it produces all the getters, it produces the constructor, the toString, the equals method, the hash code method, and yeah, it's pretty nice to use. Okay, so how do we do this? I want to think in terms of a function. I have something that takes in a user and spits out a registered user, right? It's called register user, and we'll hook this in as we go. So maybe return user. This function is going to say new registered user of user tier dot values, and then we'll say tier. Let me do one more thing here. We want to get a random number. Again, don't do this at home for random number generation. This is a demo. Okay. Okay. So tier.values.length, right? And so we're here just randomly pulling one of the tiers out of the enumerations list. There we go. Oh, where's my? Oh, there we go. Oh, this is what we're missing right here. Yeah.
Not using random.
I need rand.nextInt. And then we'll go like this. Just testing, y'all. And then so next int of length, okay. And so there. So this should give us our random user generator, if you will. So we have a function, but what do we do with that? Really, we want this user parameter to be an input from our user topic. We want to generate a registered user, and then we want to write it back out to the registered user topic. And so this is where Spring Cloud Stream and its binders come into handy. And so what we do, if we register this function as a bean, and then we come over here to our YAML, I can do Spring Cloud Stream.
Did you add the binder as a dependency to the project?
Thank you.
Yeah.
Yep. That's another test. Okay. Dependencies. So if I come back here to Pulsar, you see that Spring Cloud Stream is an option. And so, oh, not that. We'll copy all this over. Come back here. Boom. We'll pop Gradle. We'll come back here, and then now if you come in here, oh, we got highlighting. And so let's say Spring Cloud Stream bindings. Let's register user in 0 destination. We have to bind it to the topics. Tell a little bit about where it's coming from or going. So the input's going to come in from the user topic. The producer is going to use native encoding. You want to talk about that for a minute?
The native encoding is that Spring Cloud Stream provides this feature of message conversion by default. Like if you don't specify anything, Spring Cloud Stream will try to convert the message. There is a flag that Spring Cloud Stream provides in which you can disable that and let the messaging broker itself or the messaging middleware handle all the message conversion. So you can enable your native encoding, which means that Spring Cloud Stream will stay back from doing any message conversion and let Pulsar perform any kind of serialization. That's what that flag is for.
Let me copy this out here. We have to give it a little bit more information for Pulsar to tell us what kind of Pulsar bindings destination. This is going to be a consumer message type.
So Spring Cloud Stream here essentially adds a layer on top of the stack. Like you have Pulsar Java APIs, and then you have Spring for Apache Pulsar, which is the fundamental library that Spring provides. And then you can have another layer on top if you want to simply focus on the business logic and then don't worry about anything Pulsar related. And if that is the case, then you go ahead and use Spring Cloud Stream. As you can see here, you just need to drive your application using configuration properties. You can basically dictate how you want your application to perform or work based on Spring Boot configuration properties via the binder.
This first highlighted, that binds it to the input parameter. This binds it to the output parameter. And so the theory is, if we come back over here, and let me adjust this such that our listener now looks at the registered user topic instead of the user topic, takes in a registered user instead of a regular user. And what we should see now is tier information as we come through here. And let's push the button. And produce, consume. So basic, free. And so we were able to take make a produce, a consume, put in the middle between it a Spring Cloud Stream function, and that was pretty easy. We have about 7 minutes. Y'all have heard GraalVM this, GraalVM that. So we have GraalVM support. Let's stop right here and let's note something. Let's look at the startup time, what we have without GraalVM, 1.8 seconds. So remember that number. What we're going to do is we're going to drop down here to the terminal. And I'm going to make sure I'm running GraalVM's JDK, and we will do a Gradle native. Oh, almost again. Well, I had that bad habit of not coming back over here. We need one thing: GraalVM plugin. Okay. So if I come back over here to explore, what that did was add this little plugin at the top. It would have been very embarrassing if we ran for the 2 minutes and then we didn't have that. It wouldn't work. Okay, so I copied it. Let's come back over here. This will be the last time we jump back and forth there. I need to add a little tidbit in here otherwise we'll have a really annoying warning because of Java 17 about add opens. So let me pop Gradle again, and then we'll come back over here. What we're going to do is say Gradle native compile, and this is going to run the GraalVM compiler. Now, let me do this. It's a trade-off. Instead of taking 2 seconds to start up, it's going to take 2 minutes to build. So but then once we come and run it again, it's going to be very fast, and we'll show that. So it was 1.8 second startup time right now. Let's kick this off. While we're doing that, let's make the most of our time, and we can, the elevator music. Or we can talk about, take this time. Soby, would you like to talk about what's coming next?
Sure.
There we go.
All right, so we're gonna have the Spring Pulsar 1.0 GA release happening pretty soon. So before that, we are trying to address a few important features like virtual thread support, the Project Loom that we heard at the keynote today, and then the Project Crack support, coordinator, restore, checkpoint support. We're going to add it into the 1.0 release line, and then transactions are going to come. Pulsar provides native support for transactions, so we're going to see how we can address that in Spring Pulsar post 1.0 release. I say 1.1.
It'll be a big hit. But yeah.
But virtual threads and crack will have it as part of 1.0. And then the automatic failover support between, if you have multiple clusters, Pulsar allows you to, failover between the clusters. So we're trying to see if we can address that. So this project is, at the moment, it hasn't hit GA yet. It's still kind of incubating, evolving. So we are looking forward to the community. You tell us, what do you think about it? What kind of features that you want from the project? So if you can go to the project site and then on Spring side to the repository, and then star the repository, find any bugs, file issues. If you have any feature requests, let us know. And more importantly, if any of you want to contribute to the project, it's like a very greenfield project out there. It's a relatively newer Spring project. So if you want to get involved with open source development, this is a great opportunity for you to get involved at the very bottom, layer of, or things where we are, trying to build up the project. So it's a great opportunity for anyone who wants to get into OSS development.
So Soby mentioned that it's in a GA state right now. A experimental state. We call it a mini experimental GA because it's production ready, but it started off at this. We always start off projects in experimental repo, and so this is what it looked like yesterday, if you will. We had the core, the auto configuration, and the binder all in a single repo. And really where these things belong, and this is where we want them to be, and they're in process. This is moving right now. There's PRs out there. The auto config goes to Spring Boot in 3.2. The binder goes into Spring Cloud Stream proper in 4.1. And each one of these pieces, and if you compare this to Kafka, our Spring Kafka offering, it's the same way. There's Kafka auto configuration, there's a Kafka binder, there's Kafka core. This is the final resting place. And so where the GA is close, you can look for it about the same time that Spring Boot 3.2 goes, if everything goes to plan.
Just one more thing I want to add. This is not like a competing project with any other messaging projects in Spring. Our philosophy is that we are neutral when it comes to what messaging technology that you want to use. If you want to use Kafka, and if you want to use Spring, there is a Spring for Apache Kafka project. There are binders for Kafka. If you want to use the RabbitMQ, there's a Spring MQP project, and there are binders in Spring Cloud Stream. Go use that. The same vein of thought, if you want to use Pulsar, sure, there's a Spring for Apache Pulsar now. There are Spring Cloud Stream binders, and soon there are going to be Spring integration support also, the messaging inbound, outbound channel adapters and Spring integration. So Spring provides all these different choices that you can go ahead and then select. So.
Yep, good point. Okay, so what about GraalVM? Oh, let's see if we had enough time to get some results over here. Yeah, okay, it took a minute and 51 seconds to build, not bad, but what's it gonna do for us? It says the output was put in the build folder. Let's execute it and see what is this all about. Okay, it created this executable called Pulsar because that's the name of my application. Let's see what it does. That's pretty fast, 0.23 seconds, right? And so you're gonna see the produce, consume. It's the same program. It went from 1.8 to 2.2 seconds for a startup. So this is in that same vein of let's make things start faster for scale to zero cross initiative. So that's it. We have 1 minute and 36 seconds. I would love to code for another 30 minutes. It's always fun, but this is Q&A time.
If you have any questions, please let us know. If you have any comments, feedback, concerns.
And here is some other information. So yeah, Soby mentioned the contribution. If y'all want to, another good thing is it's all Java 17, all Spring Boot 3. So if you're somewhere stuck on Java 8 and you want to get a little taste of something different, just ping us on GitHub. We'll find something fun to work on. Yeah. Chirp.
If you don't have questions, thank you all for coming.
Yeah, thank you all.
Yeah.